Truth tables show us the outcome for different statements. They are helpful tools to help us evaluate statements in Boolean form. Here are yesterday's tools with 2 inputs. So the AND gate. The things we know about the AND gate is when we have 0 and 0, we get a negative outcome. When we have a 1 and a 0, we have a negative outcome. Similarly, if we have a 0 and a 1, we have a negative outcome. In fact, the only positive outcome we have in an AND gate is when we have 2 1s together. So 2 positive 1s give us a positive outcome. In an OR gate, you must have either one or the other, as the name suggests. So a 0 and a 0 is a 0. A 1 and a 0, because we have an A, we have a positive outcome, which is a 1. We have a 0 and a 1, which again is a 1. And then we have 2 1s, and in this case it's an OR gate, so this is acceptable. The outcome is 1. NOT gates essentially flip the input, so if you put a 0 into a NOT gate, a 1 pops out the other side. And if you put a 1 into a NOT gate, a 0 pops out the other side. Then we have a NAND gate. A NAND gate is the opposite of the AND gate. Therefore, the easy way to remember it is to remember your AND gate, and if you get an AND, everything that was a 0 in an AND gate becomes a 1, and everything that was 1 in an AND gate, so the bottom one, becomes a 0. A NOR gate is the opposite of an OR. So again, if you remember the OR gate, you can just flip it. Everything that is 1 in an OR gate becomes a 0, and everything that was 0 in the OR gate becomes a 1. The final thing is an exclusive OR. An exclusive OR means it has to be one or the other. You can't have both. Therefore, a 0 and a 0 is still 0. A 0 and a 1 is a 1. A 1 and a 0 is a 1, because it can either be one or the other. However, when you have 2 1s, unlike the OR gate, this is a 0. Okay, we're now going to have a look at one of the statements from yesterday. If there is no oil or no windscreen wash, then we sound an alarm. So we identify that we have 2 NOT gates and we have an OR gate. Okay, so when we see not A, we can say that we definitely meet the criterion. So we can put in a 1. And then when we have a not B, we also have a 1. However, if both are on, and if you compare this to truth tables, this happens to be a NAND gate.